Anchor is the easiest way to make a podcast. Anchor gives you everything you need in one place for free, which you can use right from your phone or computer. Creation tools allows you to record and edit your broadcast so it sounds great. And they even distribute your broadcast for you so that it can be heard everywhere. Spotify, Apple Podcasts, and Google Podcasts. So make sure you download the Anchor app or go to anchor.fm to get started.
Hello, everyone, and welcome back to another math session with me. I was about to say us, but it's just me for this math session. And as you can see, Andrew FRETT, he is not with me on today for this math session, but he will be back next week for week number, I'm so sorry, you guys. Week number 4. It's today's Friday. I'm exhausted, but anyways, he'll be back for next week for week number 5. So this is day number 6 of our math session. So today, math session to my 8th graders. We are still talking about square roots. So today we are talking about, I told you guys that for today, we're going to be talking about cube roots because if you join me on for Monday or if you watch it, that on Monday, we talk about cube roots and a little bit of perfect squares. And I didn't show you guys a video of perfect squares because we ran out of time. So today I'm going to do perfect squares first, show y'all a video of that, an example, and then dive into cube roots. So now I'm going to do something a little different here. So instead of me like doing it, teaching you guys like right now, doing it live, I actually recorded this week's lesson, you guys. So I will show you guys that, and I will be back with more. So pay attention to this video that I am showing you right now. Hello, my 8th graders, and welcome back to my math session. Now, on today, you guys, we are still talking about square roots and cube roots, which I'm going to get into on today's lesson. So just a little recap, you guys, of what we did on Monday. We talk about square roots. And as you can see on your screen right now that I'm sharing, this is what we did on Monday. So this is just like a recap, a review. So we talk about square roots, you guys. And what is a square root? Well, it's a number is one of its 2 equal factors. And as you can see right here, the example that they have, well, here's the example right here, but using symbols, A is the square root of B, if A squared equals B. So here's the example that they show us. The square root of 36 is 6, since 6 times 6 is 36. So that is a square root, you guys. That is the square root. And when we come down here, you see that the square root of, hold on, you guys, you see that the square root of 49 is 7. Well, how is that 7? 7 times 7 equals 49. And if you do 7 to the second power, 7 to the second power, that equals 49 because 7 times 7 equals 49, you guys. And then we have another one. The square root of 81 is 9. How is it 9? You guys, 9 times 9 equals 81. And then 9 squared, that's the same thing as 9 times 9, which gets you 81. And as you can see right here, they have the square root of 49 is read as the square root of 49, just as I got through saying. So, and then also what we did is we kind of talk about a little bit of perfect squares, but I am going to show you guys a video that I didn't show on Monday's lesson, and we're going to do that very quickly. So this is just a recap of what we did here. So let me show you guys the video. And pay close attention.
So now we can say that a perfect square is a number that can be made by multiplying a whole number by itself, by squaring any whole number.
Cool.
So now we can revisit the two perfect squares from earlier, and that was the 4 by 4 square and the 8 by 8 square. Now 4 times 4, if we think of this in terms of area.
Let me go back, you guys, to that definition right here. A perfect square is a number that can be made by multiplying a whole number by itself. That is what a perfect square is, and they're going to show you guys the example.
And 8 times 8 is equal to 64, which we know is equal to 8 squared. Notice again that 4 and 8 are both whole numbers.
Correct.
Now, if we take the square root of 16, our result is 4. And if we take the square root of 64, our result is 8.
Very simple.
So the most important thing to take away from this lesson is that relationship between a perfect square and its square root. And now we can explore that relationship a little bit more. Let's take a look at an example of a perfect square of 25 and a non-perfect square, 30.
Pay close attention to this right here. Pay close attention.
Now 25 is a perfect square because 25 is equal to 5 squared.
Don't you guys just hate ads? YouTube ads? I certainly do.
Squared. And the square root of 25 is equal to 5, which is a whole number, so by definition, everything works out. A non-perfect square, 30, if I take the square root of 30, I get approximately 5.48, which of course is not a whole number. So there is no whole number that we can square to get to 30 the way that we can square 5 to get to 25. Now 25 and 30 are pretty close to each other in value. And if we think about these two numbers in terms of area, again, we know that 25 is a perfect square that has dimensions 5 by 5.
And I did this on Monday right here where he's doing the area. Remember, you guys, that we was trying to find the area of 25, and it was right up here and then right here. So, yeah.
And if we think about that area in comparison to that 30, if we slide it over, we see that it kind of fits, but there is some room left over, that orange space, which doesn't quite hold one full square. It only holds about half of a square, which is where that 0.48, that decimal, comes from. And again, this is because there is no whole number that we can square to get to 30. We'd have to have a decimal value in order to approximate a square root for a number like 30. So now we're going to go ahead and visually explore some of the most common perfect squares and their relationship to their square root. So 1 squared is 1.
I'm going to stop here because we do not need to listen to all this, but you guys get the point. You guys get the point. So I hope you wrote this down, the definition of a perfect square, which is a number that can be made by multiplying a whole number by itself. So I hope you guys got that down. Now we're going to shift into cube roots. We're going to talk about cube roots today and their relationships to square roots. So once this pops up, and we're going to watch probably the whole thing of this lesson here. So get out your pencil and your notebook and take notes.
For example, if I were to tell you that 7 squared is equal to 49, that's equivalent to saying that 7 is equal to the square
Apologize, you guys, for these
square root
ads.
of 49. The square root essentially unwinds taking the square of something. In fact, we could write it like this. We could write the square root of 49. So this is whatever number times itself is equal to 49. If I multiply that number times itself, if I square it, well, I'm going to get 49. And that's going to be true for any number, not just 49. If I write the square root of x, and if I were to square it, that's going to be equal to x. And that's going to be true for any x for which we can evaluate the square root, evaluate the principal root. Now, typically, and as you advance in math, you're going to see that this will change. But typically, you say, okay, if I'm going to take the square root of something, x has to be non-negative. X has to be non-negative. This is going to change once we start thinking about imaginary and complex numbers. But typically, for the principal square root, we assume that whatever's under the radical, whatever's under here, is going to be non-negative. Because it's hard to square a number, at least the numbers that we know about, it's hard to square them and get a negative number. So for this thing to be defined, for it to make sense, it's typical to say that, okay, we need to put a non-negative number in here. But anyway, the focus of this video is not on the square root. It's really just to review things so we can start thinking about the cube root.
Correct.
And as you can imagine, where does the whole notion of taking a square of something or a square root come from? Well, it comes from the notion of finding the area of a square. If I have a square like this, and if this side is 7, well, if it's a square, all the sides are going to be 7. And if I wanted to find the area of this, it would be 7 times 7. Or 7 squared. That would be the area of this.
Correct. We did this on Monday, you guys. Remember, I showed you guys, and then what I showed you guys in the last video. And around here, I have 5. And then we was trying to find the area of 25. And I had 25 right here where 7 squared is. So, yeah.
Now, or if I were to say, well, if I have a square, and that doesn't look like a perfect square, but you get the idea, all the sides are the same length. If I have a square with area x, if the area here is x, what are the lengths of the sides going to be? Well, it's going to be square root of x. All of the sides are going to be square root of x. So it's going to be square root of x by square root of x, and this side's going to be square root of x as well, and that's going to be square root of x as well. So that's where the term square root comes from, where the square comes from. Now, what do you think cube root? Well, same idea. If I have a cube, let me do my best attempt at drawing a cube really fast. If I have a cube, and a cube, all of its dimensions have the same length, so this is a 2 by 2 by 2 cube. What's the volume over here? Well, the volume is going to be 2 times 2 times 2, which is 2 to the 3rd power, or 2 cubed. This is 2 cubed. That's why they use the word cubed, because this would be the volume of a cube where each of its sides have length 2. And this, of course, is going to be equal to 8. But what if we went the other way around? What if we started with the cube, or what if we started with its volume? What if we started with the cube's volume, and let's say the volume here is 8 cubic units. So volume
Write this down.
is equal to 8.
Write this down.
And we wanted to find the lengths of the sides. So we wanted to figure out what x, figure out what x is, because that's x, and that's x. It's a cube, so all its dimensions have the same length. Well, there's 2 ways that we could express this. We could say that x times x times x, or x to the 3rd power, is equal to 8. Or we could use the cube root symbol, which is a radical with a little 3 in the right place. Or we could write that x is equal to, it's going to look very similar to the square root. This would be the square root of 8. But to make it clear that we're talking about the cube root of 8, we would write a little 3 over there. In theory, for square root, you could put a little 2 over here, but that'd be redundant. If there's no number here, people just assume that it's the square root. But if you're figuring out the cube root, or sometimes people say the third root, well, then you have to say, well, you have to put this little 3 right over here in this little notch in the radical symbol right over here. And so this is saying x is going to be some number that if I cube it, I get 8. So with that out of the way, let's do some examples. Let's say that I have...
All right, let me stop this here so you guys can write all of this down, because he went pretty fast here. So copy all of this down here, you guys. And this is very important, you guys. You guys will be doing this, trust me. Trust me, trust me. And this will be like this, you guys, every time, every time. And some of you guys are probably wondering, where did the 8 come from? Well, you guys, first off, I'm going to say this again, and I'm going to keep saying it. You need to know your multiplication facts. 8th graders know your multiplication facts, because what's 2 times 2? It gets 4. Then you have 4 times 2, which gets you the 8, you guys. And it is also the same thing as 2 to the 2 cubed, or you could say 2 to the 3rd power, whichever. It's still the same. It's going to get you 8. It is the exact same thing as this right here, you guys. The exact same thing. And what he's doing down here. And make sure you get this down over here, the non-negative. All right, let's continue.
Let's say that I want to calculate the cube root of 27. What's that going to be? Well, if I say that this is going to be equal to x, this is equivalent to saying that x to the 3rd, or that 27 is equal to x to the 3rd power. So what is x going to be? Well, x times x times x is equal to 27. Well, the number I can think of is 3. So we would say that x, let me scroll down a little bit, x is equal to 3. Now let me ask you a question. Can we write something like, can we pick a new color? The cube root of, let me write negative 64.
Okay, let me stop here. And some of you guys are wondering, where did he get this 3 from? Okay, he did 3 times 3, which gets you what? 9. Then you have 9 times 3 gets you 27 here. You guys, this is not hard to get. It's not complex. This is so simple and easy if you guys just know your multiplication facts. Okay, now pay attention to this example that he's doing, because he is doing a negative number here, a negative number. So pay attention.
I already talked about that if we're talking the square root, it's fairly typical that, hey, you put a negative number in there, at least until we learn about imaginary numbers. We don't know what to do with it. But can we do something with this? Well, if I cube something, can I get a negative number? Sure. If I say this is equal to x, this is the same thing as saying that negative 64 is equal to x to the 3rd power. Well, what could x be? Well, what happens if you take negative 4 times negative 4 times negative 4? Negative 4 times negative 4 is positive 16, but then times negative 4 is negative 64, is equal to negative 64. So what could x be here?
Let me stop here. Let me stop here, you guys. Okay, let me break this down to you. You guys are probably thinking that it's going to turn into positive. It has to be a positive number. No. That's not the case, because what he did here, A negative times a and I said this, I believe this on Monday or last week, a negative number times a negative number gets you a positive answer. But when you do the opposite, a positive number times a negative number gets you a negative number. So a -4 times -4 will be a positive 16. But when you do positive 16 times -4, it gets you negative 64. It will not be a positive. Okay, I hope you guys got that.
Well, x could be equal to -4. X could be equal to -4. So based on the math that we know so far, you actually can take the cube root of a negative number.
Yes.
And just so you know, you don't have to stop.
Yes, you can. You can.
There. You could take a 4th root. In this case, you would have a 4 here, a 5th root, a 6th root, a 7th root of numbers. And we'll talk about that later in your mathematical career. But most of what you're going to see is actually going to be square root, and every now and then you're going to see a cube root. Now, you might be saying, well, hey, look, you just knew that 3 to the 3rd power is 27. You took the cube root, you get x. Is there any simple way to do this? And if I give you an arbitrary number, if I were to just say, I don't know, if I were to say cube root of 125. And the simple answer is, the easiest way to actually figure this out is actually just to do a factorization, in particular a prime factorization of this thing.
Do a factor tree. Do a factor tree, you guys. And I will show you guys that next week.
Right over here, and then you would figure it out. So you would say, okay, well, 125 is 5 times 25, which is 5 times 5. All right, so this is...
Okay, let me stop here. Yes, when you're doing a factor tree, this is what it looks like. What gives me 125? Well, 5 times 25, but that's 5 times 25. It gives you 125. And then, of course, you should know this. What gives me 25 here? 5 times 5. And then you can also do it over here, but it just gets you, what gives you 5 or 1 times 5.
It's the same thing as the cube root of 5 to the 3rd power, which of course is going to be equal to 5. If you have a much larger number here, yes, there's no very simple way to compute what a cube root or a 4th root or a 5th root might be. And even square root can get quite difficult. There's no very simple way to just calculate it the way that you might multiply things or divide it.
Correct, you guys, correct of what he was saying. So I hope you guys understood what he was talking about, you guys. What he was easy, very easy. Let me go back to...
So if I say this is equal to...
Okay. What he did here, you guys, is just basically you guys knowing your multiplication facts. Okay, you have to know it. You have to know it because it's very simple. It is very simple if you just know it. All these numbers here, you should know that 7 times 7 is 49. 7 squared is the same thing as 7 times 7. It gets you 49. So 7 equals the square root of 49, or the square root of 49 equals 7. And then over here, I said this earlier, 2 times 2 times 2 gets you 8. Wow. 2 times 2 is 4. 4 times 2 is 8. So 2 cubed is 8. Then down here, a negative number times a negative number gets you a positive answer. So -4 times -4 is 16. But a positive number times a negative number gets you a negative answer. So 16 times -4 is -64. Then when you come down here, The cube root of 27 is 3 because 3 times 3 is 9. Then 9 times 3 is 27. Okay, let's go on to this last video I have. And it's just 4 minutes long. We're going to do cube root of a negative number, and these are some examples. So in this problem right here, we are going to find the cube root of the cube root of, sorry you guys, we're going to find the cube root of negative 112. So pay attention to here, and then he's also going to show you I believe another example of this. So write this down before I start it, and make sure you are copying down notes. All right, let's begin.
Cube root of negative 512. Or another way to think about it is if I have some number and it is equal to the cube root of negative 512, this just means that if I take that number and I raise it to the third power, then I get negative 512. And if it doesn't jump out,
sorry you guys, another ad.
Out at you immediately what this is the cube of, or what we have to raise to the third power to get negative 512. The best thing to do is to just do a prime factorization of it. And before we do a prime factorization of it and to see which of these factors show up at least 3 times, let's at least think about the negative part a little bit. So negative 512, that's the same thing. So let me rewrite the expression. This is the same thing as the cube root of negative 1 times 512. Which is the same thing as the cube root, of negative 1 times the cube root of 512.
Correct.
And this one's pretty straightforward to answer. What number, when I raise it to the third power, do I get negative 1? Well, I get negative 1. This right here is negative 1. Negative 1 to the third power is equal to negative 1 times negative 1 times negative 1, which is equal to negative 1. So the cube root of negative 1 is negative 1. So it becomes negative 1 times this business right here, times the cube root of 512. And let's think what this might be. So let's do the prime factorization. So 512 is 2 times 256. 256 is 2 times 128. 128 is 2 times 64. We already see a 2 3 times. 64 is 2 times 32. 32 is 2 times 16. We're getting a lot of 2's here. 16 is 2 times 8. 8 is 2 times 4, and 4 is 2 times 2. So we got a lot of 2's if you multiply them. So essentially, if you multiply 2, 1, 2, 3, 4, 5, 6, 7, 8, 9 times, you're going to get 512, or 2 to the 9th power is 512. And that by itself should give you a clue of what the cube root is. But another way to think about it is, can we find, there's definitely 3 2's here, but can we find 3 groups of 2's, or can we, if we could also find, let me look at it this way. We can find 3 groups of 2 2's over here. So that's 2 times 2 is 4, 2 times 2 is 4. So definitely 4 multiplied by itself 3 times is divisible into this. But even better, it looks like we can get 3 groups of 3 2's. So 1 group, 2 groups, and 3 groups. So each of these groups, 2 times 2 times 2, that's 8. That is 8. This is 2 times 2 times 2, that's 8. And this is also 2 times 2 times 2, so that's 8. So we could write 512 as being equal to 8 times 8 times 8. And so we can rewrite this expression right over here as the cube root of 8 times 8 times 8. So this is equal to negative 1, or I could just put a negative sign here. Negative 1 times the cube root of 8 times 8 times 8. So we're asking our question, what number can we multiply by itself 3 times, or to take it to the third power, to get 512, which is the same thing as 8 times 8 times 8? Well, clearly this is 8. So the answer, this part right over here, is just going to simplify to 8. And so our answer to this, the cube root of negative 512, is negative 8. And we are done. And you could verify this. Multiply negative 8 times itself 3 times. Well, let's just do it. Negative 8 times negative 8 times negative 8.
Remember, you guys, what I said, a negative number times a negative number gives you a positive answer. But when you do a positive number times a negative number, it gives you a negative. So watch.
Negative 8 times negative 8 is positive 64. You multiply that times negative 8, you get negative 512.
See? I told you, negative number times a negative number gets you a positive answer. But when you do a positive answer times a negative number, it gets you a negative answer. So that's my lesson here. Let me go back so you guys can
Times negative 8, you get negative 512.
copy this down here, because I know you guys didn't copy all of it down here. So I'm gonna give you some time. You can take a picture of this, screenshot the screen, or do whatever. And this is my lesson on today, cube roots. And then next week, we will be reviewing cube roots and square roots. On Monday, we will review square roots and perfect squares. And then on Friday, we will be reviewing cube roots. So that's my lesson on today. So that's my lesson here for today. Thank you guys for tuning in with me for another lesson. And I hope you guys took notes, very good notes, and I hope you was listening, and I hope you know this by now. So once your teachers start talking about this, this particular lesson, you already know how to do it, and then you can help others who may be struggling with this. So that's my lesson here. And thank you guys again for tuning in, and I will see you guys back for another lesson next week, where we will be reviewing square roots and cube roots. So you guys just watch my lesson of perfect squares and cube roots. So I hope you guys was paying close attention, like I said in that video that you guys just watched, and you took notes. Please, I hope you took notes. If not, go back and rewatch it and take you some notes, because your teachers, trust me, and I keep saying this, they will teach you guys this. So you guys know how to do it now, and you can share it out with your friends. And sixth graders, if you are still watching this at this point, I hope you guys was paying attention as well, and also took notes on this as well. So thank you again for tuning in with me, and I will see you guys back next week for a new lesson. So our motto is same time, same grind, but a different lesson. So I will see you guys back next week. Bye-bye.